This is Leetcode 102, binary tree level order traversal. We have a tree like this one here, and we have to return the nodes inside of an array. But the interesting thing here is we're not just putting them inside an array like this, but we actually have to group them together by the level they're at. So it would be 3 is its own level, 9 and 20 are their own level, and 15 and 7 are their own level. So if you've studied algorithms before, you'll recognize that this is a breadth first search algorithm. Essentially, we're starting off on a node and we're looking through all of its children first. And then we get to the next node and we look through all of its children next. And then we go to this next node and then we look at all of its children, and so on and so forth. It's kind of the opposite of depth first search, which goes all the way down one particular path until it reaches the end, kind of like this. So how do we do a breadth first search? Well, we have to use a data structure called a queue. And a queue is a data structure that is FIFO, which means first in, first out. So when you add an element to the queue, that is the first element that's going to be taken out. So in the beginning here, we have the root, which is 3. So we're going to add that to our queue, and we're going to go through the queue. So while there's an element in the queue, we're just going to add to our output here. Now the question is, how do we handle levels? So instead of just storing this 3 by itself in the queue, we're actually going to store the 3 plus the current level that we're at. So we're at 3, 0. And here's our output. So here's our output, and we're going to initialize it like this. So we get to this 3, 0. We're going to add this 3 to the output at this index 0. So now output looks like this, and we pop off the queue. Now what we have to do is add the children of 3 onto the queue. So we look at them next. Okay, so now we have to add 9, and we're going to add 1 for the level, because we're on the next level, and then we're going to add 20 and 1. Right, so we do the same thing. So we get to this 9, and okay, so we add the 9 to output at the index of 1, so it's going to be a new array inside this output. Then we pop off the 9. We add the children of 9. Well, there are no children, so we don't do anything. And then we go to this 20, and we do the same thing. So we add it to the array at index 1. Now we pop off the 20 from our queue, and we add its children. So now we do the same thing for 15. This is going to be a level 2 because we're just adding 1 to the current level. And we're going to add the 7 as well. And we do the same thing. And at the end, we'll get some output like this. Now, in terms of time complexity, we have an O of n algorithm because we're just going through each element once, and that's it. In terms of space complexity, we have, well, let's see here. So we're storing a queue, and in the worst case, it's O of n at any single point. And the output also is going to be O of n because it has all of the elements from the tree. So this is O of n as well. And that's it. So if you found this helpful so far, please give a like and a subscribe because it really helps the YouTube algorithm. And let's get to the code. All right, first thing we do is we check if root is defined. If it's not, we just return an empty array. Now we define our queue. So it's going to start out with root and level 0. And we're going to define our output, which will start out with just an empty array with an empty array in it. So now while there's an element in queue, we get our node and our level from the element. So we pop off the queue. Now, if the level is greater than the length of the output, that means we need to actually add to the output. For example, if level was 1 and output had our root in already with 3, we would need to add another empty array to output like this so we could push to it. So that's all that's doing. Now, output at level dot append node val. So we're just adding the value of the node to the output array at that level. And now we just add the children to the queue. So we do node left dot append node left and level +1, and we do the same thing. So if node right, same exact thing, it's with just node right. Okay, and then at the very end, we just return output. And that's all there is to it. So again, you don't have to do it this way where you store the level alongside the node. You can actually just do another loop inside this while loop and get all of the elements in the queue and put that inside the output level. But I prefer to do it this way. It's just a little clearer to me. And the way to approach problems like these is to know that, well, okay, if you have a traversal that's going this way, you know it's going to be breadth first search. And you know breadth first search uses a queue. So if you found this helpful, please give a like and a subscribe because it really helps the YouTube algorithm, and leave a comment down below with what problem you'd like to see next. See you next time.